Okay, so today we're going to talk about measures of central tendency and dispersion. So, in order to find these, we have to know what statistics are. And statistics is just the study of data or analyzing sets of data. Measures of central tendency are just ways to represent the middle of any data set. So, here are some terms that you've heard of. You probably just didn't know that they were actually measures of central tendency. So we have the mean, which is just the average. In this section, we're going to pronounce this X bar. That's just a notation for mean. So anytime you see that X with a little line above it, know that you're finding the mean. Median, remember, is the middle number. So you find the middle, but it's really important to remember that your numbers have to be in order from least to greatest. And then the mode is just the number, or you could have multiple numbers that appear the most often. Okay, so if we need to find the measures of central tendency for these test scores, that just means that we have to find the mean, median, and the mode for these scores. So first of all, we need to make sure in order to find our median that we put them in order. So you can do that on your own paper, but I did go ahead and calculate all of these. Our mean, remember, to find your average, you add all of them up and then divide by how many terms you just added. So when you add all of them up, you get 753, and there's 10 test scores, so you would divide by 10. That gives you 75.3. I did also show it in our notation, so X bar equals that 75.3. Median, if you lined them all up, would be 74. And then our mode, there are no test scores that repeat themselves, so we would just have none. We also said we're going to talk about measures of dispersion, and that just means it's a number that tells us how spread out our data values are. So the first one that we know about is our range. That's where you take your largest number and subtract your smallest number. A new one would be the variance. So we're going to find the average of our squared differences from the mean. That doesn't really mean a whole lot. I'll show you the equation in a minute. The last measure of dispersion would be standard deviation. Standard deviation is going to tell us how far each number is from the mean itself. And variance and standard deviation are related. In order to find your standard deviation, you take the square root of your variance. So here's our equation. This little Greek symbol stands for sigma. So when you see that, just know it stands for standard deviation. Inside this square root, so if you just look at that fraction, that's the variance itself. It's the difference squared, and then average, remember, means you add everything up and divide by how many terms. So inside here is the variance, and then square root gives us the standard deviation. Okay, so we're going to do an example of that. We're going to find the range and the standard deviation for these 5 data values. So our range, we would take 17 minus 5. Our range is 12. In order to find our standard deviation, the first thing we need to do is find our mean. So when we add all those terms up, we get 55 divided by the 5 terms gives us 11 as our mean. And then to go find our standard deviation, we know we have our sigma, then the square root, and then we have our first term minus our mean squared, plus our second term minus our mean squared, plus our third term minus our mean squared, and so on. And then divide by how many terms you just added together. So we divide by 5. I went ahead and did the math. You can follow along, but you should get down to the square root of 98 over 5, which is a square root of 19.6, which comes out as roughly 4.43. So on average, each of our data values is roughly 4 units from our mean. Okay, when we look at statistics or a set of data values, we also sometimes have what we call outliers. And an outlier is just a data point or two that are substantially smaller or larger than any other of the data values. And they can really throw off your mean, median, mode, your range, or your standard deviation. So those measures of central tendency and dispersion. So we're going to look at a data set that has an outlier. So we have all these single digit numbers, and then we get up here to 68. Obviously, that's a really large outlier, but I just wanted to show you guys kind of what it does. So if we included our outlier in all of our data, our range would be 66, because 68 minus 2. Our mode is 4. Our median, our middle number, is 4. Our mean, or our X bar, is 10 2/3, so 10.66. And then our standard deviation is 20.3, which that means that on average our each data value is 20 units away from our mean. And you can just see right away that these values are all within almost 4 units of each other aside from that 68. So it doesn't make a whole lot of sense to have each of our data points be 20 units away from our mean. If you take that outlier out, I calculated everything again. Our range is only 4. Our mode is still 4, so that didn't change. Our median is 3.5. Again, the median didn't change very much. Our mean, though, is 3.5. So 10 and 2/3 to 3.5 is a huge difference. And then our standard deviation says that our data values are only on average about 1.25 units away from our mean. So definitely a substantial difference between the two. So when you're examining data points or data sets, just make sure you're aware whether there's an outlier or not, and then just know that it can sway your information some. The last thing we're going to talk about, when we have data points, a lot of times they are organized in a box and whisker plot. So in a box and whisker plot, we have a minimum and a maximum. Those are our whiskers. And then we have 3 quartiles. So I defined each of our quartiles. Our first quartile, actually, let's start with the second. The second quartile is what you find first. So it's just the median of all your data sets or data points. So just the middle number. Then your first quartile takes that lower half of the data. After you find the second quartile, you kind of cut your information in half. The first quartile takes that first half of numbers and finds the median of those. The third quartile takes the upper half of the data and finds the median of those data values. So I have an example. Here's just a small number of data values. Obviously, our minimum is 1 and our max is 10. I lined them up already, and we see that our median is 6. So our Q2, or our second quartile, is 6. We ignore that median, that Q2, and then find the median of that lower half of the data. So our median of the lower half would be 2. So Q1 is 2. And then to find Q3, the median of the upper half, which would be 8. You put that on a number line and graph it. We want to make sure we number our number line so that we have some sort of idea where we're starting and what our intervals are going. I just went by ones, minimum, maximum. There's Q2, our median is 2, Q1 is 2, and then our third quartile is up at 8.